Now we're going to look at how Blender in Python handles the objects' names. We're going to use this to create a nice little naming utility that we can reuse at the end of the course as a kind of a useful result. So if you open the file steers.blend, you're going to see that there's a bunch of teal steers in it, and all of them have the name cube. They're called cube, and then with all the .00, 1 and 2 and so forth. This is a very common occurrence that you have. There's also something that's very undesirable if you're working, especially if you're working with other people and you're working with complex files. It's really not an ideal situation to have a bunch of stuff called cube and curve and so on and so forth. So let's have a look at how these names are used, and then we're going to write a nice little utility that will let us rename a bunch of things at once. So the first thing is, let's have a look and just get our active object. So once again, we're going to do bpy.context.object, and you'll notice what comes up. So we go from this bpy.context right away to bpy.data. I'm actually going to look into this line in more detail than we have before. Before we just looked at the name, but now we're going to look at the whole line. So what we get is bpy.data.objects square bracket cube.001 square bracket. So we call out something from context and we get something out from data. And we're getting it out by name. One of the interesting things here is that in the previous section, we looked at using a list, and we put a list index usually after the square brackets. So when we did, for instance, selected objects 10, for instance, and we got the 10th object, right? But we never put in a string inside the square brackets, right? So how do we get to do that? It's a different type of collection, basically. So the first type of collections we looked at were lists, and they were ordered collections. We made them, and then we used bpy.context.selectedObjects, which works like a list. However, you can have unordered collections of objects, and you can actually look up objects using a key. In this case, the key is a string, which is the name of the cube. It could be any other kind of key, actually, as you can see. So let's make one just to see what that looks like. So I'm going to do d equal, and the syntax to making a collection like this, which is called a dictionary, by the way, that has key value indexing instead of indexed indexing, is to use this kind of curly brackets. And then inside the curly brackets, instead of just having a list of items, you have to have a list of key value pairs. So you can say, like, let's say that we want to store in like the min, max, and default values of a parameter. So you do min is one key, and let's say the minimum is 0.0, comma, max, colon, 1.0, and default is, let's say it's 0.5, for instance, right? And so now if we hit enter, now we can't actually do D0. That gives us an error because there is no key called 0 here. But what we can do is do D min like that, and then we get the number 0, and you could do max and default in the same way. And so you can basically look things up based on this this key, right? And so if you don't type in a key that doesn't exist, you just get a key error. Well, the same way bpy.data.objects works in a very similar way. It's a Blender collection type, and you can do bpy.data, And let's remember that data refers to all the data in your current blend file. You can actually see that very kind of quickly by changing your outliner to data blocks, and it actually looks a lot like bpy.data. So if I do the auto-completion here, you'll see like meshes here, and there are meshes here, objects, materials. You'll see all the same kind of things that you see here repeated over here. So if you do objects, right, and there should be an objects here, right? And this objects here is a collection. So if you put in square brackets and try to complete, yeah, you need a quotes as well. You'll see all the different items in there. And if you just hit enter, it'll just tell you that it's a collection with 21 objects. So let's try to access a specific object by name. So let's say I want to get the object named cube out of this. I would simply write cube in here, and it would give me the object. And now I can say, you know, what is its location in X, and it will give me that value, and so on and so forth, right? So that's pretty handy. You can also do things like this. Like, for instance, let's say I want to deselect that object. So I can do dot, yep, you guessed it. Oops, I just did the wrong thing here. Control space. So this is a flag that tells me if it's selected. We haven't seen this before, but it returns a true with a capital T because it's a Boolean. It can be true or false. So if we assign the word false to it with a capital F, it's going to deselect one of these guys. This one right here. So it just got deselected, and we can select it again by typing true. So now that we've done that, let's write a quick utility that will rename all the selected objects so that we can have a better naming convention for them all. I'm going to do a text editor thing again, and we create a new file. We're going to call it rename.py, and we will import bpy in our first line. I'm going to turn these guys on. So we'll import bpy, and then we're going to do a loop. The same way that we did a loop over selected objects before, we're going to do it exactly the same way again. So I'm going to do for ob in bpy.context.selected objects, like so. And this time I'm going to change the object's name, and that's simply ob.name, right, equals, and let's type out the word steer. And if I run this script, notice that all our selected objects change their name to steer. Now that's pretty useful, and it's so useful, in fact, that we might want to do it again without having to type out this loop. So how do we actually do that? Well, it'd be nice if we had a rename function that we could call, right? So we could do rename and then typed out our new name inside the parentheses like we did with functions, right? So how do we make this into a function? So now we get into the syntax for defining a function. So I'm going to go up a little bit. So the first thing we need to do is tell Python what we're going to define a function, and we use a keyword for that, which is def. And then we have to write out the name of the function. So I'll write rename, maybe rename objects, or rename selected, right? And then we have to put in a pair of parentheses, and inside this we can put in an argument. I'm going to leave it empty for now, and we're going to write a colon right afterwards, the same way we write a colon at the end of a loop. Just like loops, Python uses the indentation to tell it that we're inside a function block. So if I select this stuff and hit tab, now I'm indented inside the function block. I will now have a function. And I'm going to go to the end here. And if I de-indent, now I'm outside the function and I can actually call it. So I can type rename selected. And just so that we know that it happened, I'm going to change this to test. And let's run the script. And notice they all changed to test. So what happened here is that we defined a function. And this is what the function does, and then we called it later on. Now if we don't call the function, let's delete this line and call this oops, or oops, and run the script. Notice nothing happens, because defining the function doesn't actually run the code inside of it. You actually have to call the function for that to work. So now we have a function called rename selected, but it always renames the thing to the same name. So the next step is to give it an argument. So basically when you call it, you give it the name that you want to rename the stuff to. So let's say rename selected X, it doesn't matter what this is, and instead of oops, I'll write X, right? Now if I run this, nothing happens. But if I call it, and instead of X, I can type out what I want. And now if I run this, it actually works. Now we can actually do this from the console as well. So notice I call this rename.py. I can import rename.py, and I better delete this line if I do that. I'll explain why later. Oh, sorry, no need for the py. There we go. And now I can do rename.rename selected test. And notice they're all called tests. So you can actually import this and use it from the console. You can also do from rename import star, and then you can do rename selected without having to type rename.rename. And let's call them steer again. Now the reason I deleted the function call at the bottom here is that when you import this code, it actually runs it. So you don't want it to actually rename your selected items when you're importing, because that would be pretty bad behavior. You would want it just to define the functions, but not do anything else. That way, importing your utility script doesn't actually change anything in your file until you actually run the functions yourself to change those things. So I hope that's pretty clear. You don't really want to have active stuff, changing things in your script if you're going to import it in another file, and thus cause things to change unnecessarily.